Hello everyone, welcome to the fourth video in this series. Today we'll learn about how hexadecimal color codes work. Yeah, some of you might have dabbled in web design before. You might have seen hexadecimal color codes. And today you'll understand why those hexadecimal color codes produce the colors they do. So let's go over here. We'll look at this website, Color Display. So it's colorspire.com. Feel free to go to this website yourself and try it on your own. So let's put in some things. Let's try 59 EA44. I just made that up. Looks like it's green. Let's try another one. 505005. A very dark, vibrant yellow. Let's try here. ABCDEF. Very light blue. Okay, cool. So hexadecimal color codes are in the order of RGB. What do you think that stands for? It stands for red, green, and blue. So hexadecimal color codes have 6 digits. 1, 2, 3, 4, 5, 6. And each of these takes a hexadecimal value. So hexadecimal, as we learned from the previous lesson, how many digits does it have? 16, which means there are 16 possibilities here, times 16 possibilities here, times 16 here, times 16 here, times 16 here, times 16 here, giving you a total of 2 to the 24th, or 16 to the 6th possibilities. So if you're wondering why 2 to the 24th, right, it's because 2 to the 4th power, hold on, sorry, 2 to the 3rd power gives you, oh no, sorry, so 2 to the 4th power gives you 16. And 16 to the 6th power gives you the answer to this. So anyway, that's where these numbers came from. All right. So this is red, green, and blue. If you're looking at the exact number, it's 16,777,216. So hexadecimal color codes, they begin with this. For example, FF002A. They're always in this order: red, green, and blue. Why do we use them? Well, they're much more user-friendly than binary code. Can you imagine reading a string of 24 ones and zeros? Which one do you prefer? A string of 24 ones and zeros or this? Light display. So RGB, each of those two those digits are 2 digits for R, 2 digits for G, 2 digits for B. That represents the channel for red, channel for green, and channel for blue. 00 with a value of 0 represents fully turned off. The decimal number 255, which is FF in hexadecimal, represents fully turned on. Anything else in between is partial. So if 0 in decimal, aka denary, which is 00 in hexadecimal, means fully off, then what do you think the 6-digit hexadecimal is for black? 000000. Remember, black is the absence of all light. The absence of all light. So if 255 or FF means fully on, then what do you think is the 6-digit hexadecimal for white? Remember, white is all lights completely on. The answer is FF, FF, FF. So again, why hexadecimal? 2F in hexadecimal uses the same amount of memory as 0010, 1111 in binary. 4 bits is called a nibble. So each digit in hexadecimal is equivalent to 1 nibble. So why do we use hexadecimal? Well, it's easier to use. As we mentioned, How do you feel about reading a string of 24 ones and zeros? It's confusing and it's easy to make a mistake. You're a human being, aren't you? Which one's easier for you? This one or this one? I know what I would choose. I like this one much better. So these two are equivalent, by the way. Using the skills you learned in the previous video, you can double check my work if you'd like. So if you look at the ASCII table, we already talked about the ASCII table for decimal. For example, 65 in decimal means is encoded into the character capital A. Well, if you look at hex, 65 is equivalent to 41. Thank you for not saying 41. So what are some other uses of hexadecimal? Well, of course we use them for color, but they're also used in error messages. Hexadecimal is often used for in error messages on your computer. They tell you the memory address, so the memory location of the error, helping programmers to find and fix problems, which is known as debugging. Machine code. So machine code is not like Python or Java. Python and Java are portable. They're the same across different devices, different operating systems. Machine code is lower level language and it's machine dependent. So different operating systems could use different machine code. They could be written in binary or hexadecimal. So let's do some fun stuff. What flag is this? It's the flag of France. So imagine this is the purest blue. What do you think the hexadecimal color code is for this? Remember, RGB. There's no red, there's no green, and there is full blue. It should be 0000FF. Now, the middle of the French flag is white. So what do you think the hexadecimal color code is for this? That's right. FF, FF, FF. How about here? Imagine this is the purest red. It would be, remember, RGB, FF0000. Here's the flag for Afghanistan. Ignore the graphic in the middle. What do you think the hexadecimal color code is for this part of the flag where it's black? Maybe 000000. If this part is pure red, again, it's probably FF0000. And this part's green. Here's an interesting one, RGB. So it should be 00FF00. So why red, green, and blue? Well, as far as I know, those are the primary colors for the computer. In fact, if you've ever bought a new printer and you printed out a test paper and you saw some weird looking lines and colors and dots, they were probably testing for these three colors. Now, using this graphic to help you, feel free to pause the video. Write down what you think the hexadecimal color codes are for the following: magenta, cyan, and yellow. Go. Go ahead and pause the video. So the answers are, for magenta, it's FF00FF. For cyan, it's 00FFFF. For yellow, it's FFFF00. You can go into many different websites and just play around with the colors there. If you see here, this is 32A621. What is 32 in decimal? Go ahead, pause the video, figure that out. It's 50. Yeah, what about A6? Again, pause the video. 166. And then what's 21 in decimal? It is 33. So thank you. Thank you very much for your attention, and I'll see you again in the next video.